Hello everyone, this is BALLULLAYA from Canada Engineering College. In our today's session, let us discuss about the sparse matrix. So first of all, we have to understand what is a sparse matrix. Okay. So as per our definition, a sparse matrices or sparse matrix are those matrices which have majority of their elements equal to zero. Okay. So if I have taken an example here, students, I have taken an example here, everyone. Yes. So here we can observe that majority of the elements are zero. Okay, so if in this matrix, which is a 3 cross 3 matrix, here out of 9 elements, we have only 3 elements in which there are values. All other 6 elements in the matrix are zeros. So that is why this is a sparse matrix. So if you want to take one more example we can take. Yes, so if I do one more example of a sparse matrix, if you want, so we can also show you one more example of a sparse matrix. So if you see this example, this one is also a sparse matrix because this is a yes. No, so students, one more thing we need to understand is something. But we know that this is rows 0, 1, 2, 3. Here there are 3 rows. Okay, and here there are 5 columns. Okay, I mean 4 rows and 5 columns because row index always starts from 0. So we have to start from 0 always. So 4 rows and 5 columns, and this is a 4 cross 5 matrix. And it is a sparse matrix. Why? Because only few elements, that is only 6 entries. Okay, only 6 entries have elements, whereas all other elements are having zeros. So this is also another example of a sparse matrix. The next question is, why do we require a sparse matrix, or what is the need of a sparse matrix? So there are two main advantages of the sparse matrix. One is nothing but storage. In terms of storage, less storage is required. So why do we require a less storage? We require less storage because most of its elements are zero. So and we have already seen that. Okay, yes, so we can save a lot of storage, we can save a lot of memory if we use a sparse matrix. Another one is nothing but a computing space in terms of a computing terms. So we know that as most of the elements are zero, yes, most of the elements are zero, we can create a data structure which traverses, okay, means which goes through only the non-zero elements in the matrix. Here we store only the non-zero elements. So that means what? In the sparse matrix, we have to go through, or we have to compute the element of only the non-zero elements. We have to ignore the zeros. Okay. So that is why even lot of computing space also is saved. Okay, I mean more computing is not required here. Less computing is required. Okay, yes, so that is another advantage. We need to compute more because element is less means computing is also less. It's as simple as that. So in sparse matrix we have two kinds of representation. We can represent a sparse matrix in two ways. One is array representation. Okay, Another one is linked list representation. So let us learn about the array representation. So in array representation of a sparse matrix, we have only three fields. Okay, we have only three fields. First field is a row field, second field is a column field, third field is a value field. So here we are using 2D array. What is 2D array? It is nothing but two-dimensional array. Two-dimensional array. So two-dimensional array is used to represent a sparse matrix in which there are three rows named as row, column, value. So what is row? Row is nothing but index at row where non-zero element is located. Index. So it speaks about the index. Index at row where non-zero element is located. So here we are representing only the non-zero elements. Okay, let us see that example also. Next one is nothing but column. Column. So column is nothing but it is index at column where non-zero element is located. Third one is value, where value of the non-zero element at index. Value of the non-zero element located at index, row, column. Okay. So let us understand all these things in our when we are speaking about the in the worksheet. Okay. So we have a worksheet here. So when we are going through the worksheet, let us understand the example for both array representation and the linked list representation. Now let us understand the linked list representation. So in if we are summarizing what you need to know in array representation, you should know that you have one row field, one column field, and the value field. So this much you have to know. Now let us see the linked list representation of the sparse matrix and let us observe the changes. Let us see the changes which is there in the linked list representation of the sparse matrix. So next we are coming to the linked list representation of the sparse matrix. Here each node has four fields. Here four fields. So in the array representation we had only three fields. Here we have the four fields. First one is nothing but as common to your array representation, a row. That is nothing but index at row where non-zero element is located. Next one is column, that is index at column where non-zero element is located. Next one is value. So this is value of the non-zero element located at index, row, column. So these three are common to our array, common as array representation. Next, the additional thing in the linked list representation, which also makes linked list representation different to the array representation, is nothing but the next node field. The next node field. This field is a special field in the linked list representation, which will take care of the address of the next node. Which will take care of the address of the next node. Yes. Okay, now let us understand what exactly is the array representation of the sparse matrix. Now, till now we have understood the theory of the array representation of the sparse matrix. Now let us see the working, okay, of the array representation. Let us see how exactly our array representation looks like. So to understand that, we need to take one example. So let us take one example matrix. So we have the 4 cross 5 matrix here, 4 cross 5 matrix. So what do you mean by 4 cross 5 matrix? 4 cross 5 matrix means you have 4 rows and 5 columns. And remember, always left to right representation is nothing but rows, and top to bottom, that is vertical, it is columns. Remember. So according to that, we have 4 rows here. Zeroth row, that is first row, second row, third row and fourth row. And why we are starting with 0? Because always the index starts from 0. Yes, so we have 4 rows here and we have 5 columns. Okay, that means what? We should have 20 elements in total. We should have 20 elements. So we have 5 columns here. Okay, now how do we represent in array representation? Though this is a matrix, okay, this is a matrix, a simple matrix, and we also know that it is a sparse matrix because out of 20 elements, only 1, 2, 3, 4, 6 elements have the values, other 14 elements doesn't have value. So it's a sparse matrix. And what does sparse matrix tell? The definition of a sparse matrix tell that it is a sparse matrix are the one in which majority of the elements are 0. Okay, so let us now do the array representation. So first field is a row field. Okay, next one is a column. So I told you it is stored as a row, so that is why I am showing it that way. And next one is nothing but a value. And we know that 6 fields are there which is having value here. So what we are supposed to do is nothing but we will have 6 entries here. We'll have 6 entries. Now here, this is the first entry, second entry, third entry, fourth entry, fifth entry, and one more entry is required. 6 entries totally. Okay, now let us start from the first row, first column. So students, we know that first row, first column we have 0. So we don't write the elements which has 0. We only write the non-zero elements according to definition of the sparse matrix. So here first we get at row number 0 and column number 2 we get value. So row number 0 and column number 2 we get the value 4. Okay, next in the continuing at the same pace we can also write. Okay, let me write it in a separate color so that it will be useful for you and it will be easy for you to understand, guys. Okay, so what did I write? That is nothing but at the 0th row, at the second column, that is 0th row, second column, 0th row, second column, what value I have 4. So I write that. So this is over now. You need not circle it when you are doing. Okay, this is just for the understanding. I am circling it so that you will come to know that that particular element has been selected. Next is nothing but 0th row. Third column you don't have anything, so 0th row. Go to the fourth column. 0th row, fourth column you have 5. Next one is, this is also you can circle now. Next is nothing but first row. 0th column, first column, second column we have 0, so we are not selecting that. In the first row, third column we have 3 because value is also 3, students. See, whatever I am circling, it is a value, remember that. Okay, and this is the row index, column index, remember. Okay, next one is nothing but 6, that is nothing but in the first row, fourth column, first row, fourth column we have the 6, so we can circle it that way. Similarly, in the second row, third column, we have 2. Let me circle. Okay, so we can observe that there are 7 entries, students, because two more values are there, not 6 entries. Okay, there's a 7 entries. 1, 2, 3, 4, 5 is already over. 2 more are there. So we can do one more segregation there. Okay, we can do one more segregation because 7 entries are there. No, you need to write all the entries, then only it will be correct. Yes. Now let us go to the next one. Sorry. this column. Correct, no? Yes. Next one is nothing but the third column, third row. Here we write the row index. Okay, so here we write the column index, third row, first column. We have 2. Okay, so according to our normal number, it is second column, but here since it starts from 0, it is the first column. Next one is last element, that is 3. Okay, that is there in third row, second column. You have 3. This is how you represent the array representation. This is nothing but the array representation. Now, if you see the definition and compare, you will understand array representation of a sparse matrix. So this is the all concept of a thing. So what is this, students? Okay, let me do this. What is this in the whatever is there in the first column? Okay, whatever is there in the first row, that is nothing but row index. So all these are the row index. Okay. Yes. So all entries. Okay, all entries. You can mark here for the this thing to be more clear. Okay. Yes. Now, what are these? Let me do it in a separate ink. Just take the purple over here. What are these, students? These are the column index. Okay, I can take it here and I'll do it. Column index. And what is our last row? These are the values. Are the values. Okay. At given row and column. Given row and column. Okay, all these values. You can put a arrow there and you can make it very clear. So this is all we have in the array representation of a sparse matrix. Now let us understand the linked list representation of the sparse matrix. Now let us understand the linked list representation. We have another worksheet here. Now here let us understand the linked list representation. Now once again, student, to draw a linked list, we need a here also we need a matrix first. Okay. I will take the same example for simplicity. Okay, this is a different example, but no problem. It's a 4 cross 5 matrix. Okay, so again we have here 4 rows and we have here 5 columns. It is a 4 cross 5 matrix. 20 elements. And if you observe how many elements with values here 1 2 3 4 5 6. Yes, so here we have 6 elements with values. So of course it is also a sparse matrix. Okay, now how do you do the linked list representation? Let me take a separate ink. Yes. So here, students, you will have a 4 fields. This one is for row. This is a node, students, single node, and for every node it is same. This is column. This is a value, and this is a we'll write it down as we don't have any space. So the address of next node. So basically it will be a pointer. Okay. So in our first node, in the same fashion how we did our array representation, in the same fashion we need to do this also, a linked list representation. So here also we are going in order, that is nothing but 0th row. Let me yeah, total. First let us draw the nodes, students, because it will be comfortable for us later on to write the in same ink. Okay, so we'll have 6 values, means we'll have 6 nodes. Okay. As space is not there, I am just bringing it down. Okay, and I am continuing here. And here it will be null, because the last pointer will always be pointing to the null. Okay. Yes. So let us start filling the values in our representation. Okay. So it is first of all 0th row, you come in order, 0th row, second column, 0th row, second column, we have the value 3. Okay, and this is nothing but a point address of the next node. That address can be anything. Okay, say if you give your own address like 150 here, then this will be 150. Okay, as simple as that. Okay, so we'll that is the simply the concept, that's all. Okay, I mean any address it can be. Okay, let's not get confused there with this. Let us just be busy in filling our values. Okay. Next one is nothing but 0th row. I have, that is in 4th column. Okay, 0th row, 4th column. You have to number according to the index only. You have the value 4. Okay, and this is also once again address with the next node. Then you have first column. We are going in order. You have to see the matrix and you need to fill both array and the matrix array and both array and the linked list representation. First row, second column, you have 5 value. So this once again address to the next node. Next one in first row, third column, you have 7. So for let us represent the addresses by a cross here for the time being. Next one, in second row you don't have anything. In third row, first column, you have 2, and last entry, that is in your third row, second column, you have 6. Now we are coming to the end. So this is the linked list representation. Linked list representation. So this will be null, students. Okay. Presentation of a sparse matrix. And cross, it signifies some address. Some address. Okay. Some address. Some address means some address set of some address of next node. Some address of next node. That is important. Next node's address. Okay. So this is the linked list representation of the sparse matrix. So that is all we have from the sparse matrix. And sparse matrix is nothing but it is one of the application of the linked list. Okay, one of the applications of the linked list. Okay, thank you everyone. So this is what we have from this video. Thanks a lot.